So we have here the following emitter circuit with an NPN transistor in the middle, a load resistor at the collector, an input voltage at the base, an output voltage at the collector, and the emitter of the transistor is at ground. So how do we calculate the input resistance of the transistor if you look at this point into the transistor? Basically, for this we can look at the small signal equivalent circuit, which basically looks something like this. We again have the input voltage at the base, we have the input resistance, we have the output voltage at the collector. And basically this thing here is a transistor. We have the base emitter resistance, the collector emitter resistance, and a current gain. So how do we calculate the input resistance? Well, for that we have to look into the circuit from this point, and basically we just have the base emitter resistance. The input resistance is basically just the base emitter resistance. So what about the output resistance? What if we would look at this point into the transistor? Well, that would basically be just here. So the output resistance is just the collector emitter resistance. And those are the formulas for the base emitter resistance and the collector emitter resistance. Now, how do we calculate the voltage gain? The voltage gain is defined by output voltage divided by the input voltage. So we have the output voltage here and the input voltage here. We'll make it a little easier. We'll look at this point, the input voltage dot. So what is the output voltage divided by the input voltage dot? Well, the output voltage goes over these two in parallel. The input voltage means the voltage here flows over this resistor. Means for the voltage gain we have the output resistance, means the collector emitter resistance in parallel to the load resistor, divided by the base emitter resistor. But the current is not the same. Here flows the collector current, and here we have the base current with a minus because they're not in the same direction. So how do we simplify that? Well, we have the formula: the collector current is the current gain times the base current. So if we replace the base current by the collector current divided by the current gain, we basically get this formula. So the collector current just falls away. And if we replace the base emitter resistor with this formula, we basically just get this formula with the collector current divided by the terminal voltage. And this is basically just the transconductance of the transistor. So we get to the final formula, the transconductance times the collector emitter resistance in parallel to the load resistance. And yeah, this is the voltage gain from the input voltage dot to the output voltage. If we now want to calculate the voltage gain from the input voltage to the input voltage dot, well, that's basically just a voltage divider. So we would get Vin dot divided by Vin is Rn plus Rb divided by Rn. Now if you want to calculate the final voltage gain of the whole circuit from this to that, we just multiply the two voltage gains. So we have Vin dot divided by Vin times Vout divided by Vin dot, and yeah, this just falls away and we have the final voltage gain.